Hi there, so today we're looking at lesson 9.5 on straight line graphs. The objectives today: to recognise, name and plot graphs parallel to the axes, to recognise, name and plot graphs of y equals x and y equals minus x, to plot straight line graphs using a table of values, and to draw graphs to represent relationships. As always, before we start, we need to check our prior knowledge. You should be able to use a function machine. You should be able to substitute values into an equation. You need to be able to plot in all four quadrants, and you should be able to draw suitable axes for graphs. Make sure you're happy with those before you move on. Things you'll need then: you need either your maths book or some paper to write on. You'll need a pen or a pencil to write with. You will also need a ruler for drawing straight lines, so really should have a pencil to go with your ruler. And you may wish to use your calculator. Okay, so today then to start with, we're going to have a look at lines parallel to the axes. So how do we find the equations of these lines? So when we say parallel to the axes, we've got our y-axis here, our vertical axis. We've got our x-axis here, our horizontal axis. Now line A is parallel to our x-axis. Line C is also parallel to our x-axis. So remember, parallel are like train tracks where they are in exactly the same direction, so they will never meet. We've got our vertical axis y here, and we've got line B here, and these are parallel as well. So again, like train tracks, that will never meet. So make sure you're happy with the word parallel. Now, to be able to find the equations of these parallel lines, we're going to start by writing down at least 3 of the coordinates of line A. So if we look at line A, all these little crosses are different points on line A. You need to write the coordinates of at least 3 of them. Okay, now it could be that one, minus 4, 3. So we've gone along the corridor, up the stairs. We might have minus 3, 3, minus 2, 3. Now that's at least 3. You may choose 3 different ones. I'll list them all just so you can see all the choices you could have. Okay, so they are all the different coordinates you could have had. You should have written at least 3 of those to help you. And what do we notice about all of those coordinates? So if we look at all of these coordinates, we've got our x coordinate here, and we've got our y coordinate here. And hopefully you notice that the y coordinate is always the number 3. So for every single point, doesn't matter which 3 you've chosen, the y coordinate is always 3. And so we would say the equation of that line is y equals 3. So we're naming it based on the fact that this number is the same throughout. So the y coordinate is always equal to 3. Let's try another one. Let's have a look at the line labelled B. So this is the line labelled B, this vertical line here. I'm going to write down again at least 3 of any of these. Again, I'm just going to do them all so you can see what they are. So we can have 4, 4, 4, 3, 4, 2. So remember, we're going along, then up to 4, 4, 4, 3, 4, 2, 4, 1, 4, 0, 4, minus 1, 4, minus 2, 4, minus 3, 4, minus 4. So again, at least 3. Now we say at least 3 because that helps us to see that there is a pattern. If I just do 2, I might not know what the pattern is. So again, what do we notice about the coordinates this time? Well, this is our x coordinate. All of our x coordinates are 4, all of our y coordinates are different. So this line is given the equation x equals 4 because all of the x coordinates are 4. So again, we've given it the equation based on the fact that there's something special about the coordinates on that line. Okay, so your turn then. So we're going to write down the equations of the lines labelled A, B, C and D. And you need to start by writing down at least 3 coordinate points on each line and then looking for that pattern. So is it the x coordinate that's the same or the y coordinates the same, and how much is it? That will help you to label them. All right, so if you pause the video now, have a go at that in your book. Okay then, so for line A, you can have any of these coordinates. So any 3 from this list, mark yours. And you should have noticed that this first coordinate, the x coordinate, is 1 for each of them. So we call that one x equals 1. Line B, oh, excuse me, I don't know why line C's come up, but we'll go back and do line B first. So line B then, you could have any of these points. So again, you should have 3 of those points there. If we look at those, then we can see that the x coordinate is -3 all the way down. So we're going to call that one x equals -3. And you can see if you look at line B, it's going through -3 on the x-axis there. So now let's have a look at line C then. So points you could have, remember you need to have at least 3 of these. So any out of these. And if we look at those, then we can see that the y coordinate is the one that's the same this time. The second coordinate is the y one. So we can call that one y equals 2. If we look at line C, we can see that it has indeed passed through the y-axis at 2. So this is a good way to check you've got your answer right. Finally, for line D then, any of the following, so 3 at least from this list. And in this time, again, it's the y-axis that's the same, the y coordinate, sorry, is the same. And we're going to call that one y equals -1. All right, so let's check. There's D, and it does go through -1 on the y-axis. Make sure you're happy with those before you move on. All right, so now that we can find the equation of a line that's parallel, can we draw the line when we're given the equation? So key point here then, when you draw a graph, it should go to the edge of the grid, and you label your graph by writing the equation next to the line. So our first step then is to copy the grid into your book. So you might want to pause the video for a moment and copy that down into your book. Okay, now that we've got that copied down then, we're going to have a go at drawing and labeling these 3 graphs. So we're going to start with y equals 5, and we're going to pick 3 coordinates for each of these lines. Now, if it tells me that y is equal to 5, that means of my 3 coordinates, the y coordinate needs to be the number 5 each time, and my x coordinate has to go between -5 and 5, because they're all the values of x that I've got on my grid here. So I'm going to pick 0, 5, 3, 5 and -1, 5. Now you could always pick 3 different ones, but I've chosen those. So I'm making sure that the y coordinate is 5 for each of the ones I've chosen. I'm then going to plot those onto my graph. So 0, 5 is there, 3, 5, -1, 5, and I'm going to draw a line to join them together. And as it says in our key point up here, my line needs to go all the way across my grid. So there's my line, and we need to make sure we label next to the line, and that was y equals 5. So let's do that for the next one then. So this one says x equals 2. So that means the x coordinate has to be 2 in all of the points I choose. So I know my x coordinate, my y coordinate needs to go between 5 and -5. So that's where my numbers can be. So I've chosen 2, 0, 2, 1, and 2, -3. So I've made sure all of my x coordinates this time are 2, and my y coordinates fall within the range of my graph. So I'm going to plot those now. So there we are. So that's 2, 0, 2, 1, and 2, -3. And I'm going to draw a line through those. You can see we get a vertical line this time, and we're going to label it x equals 2. Finally then, we're going to do y equals 3. So again, all the y coordinates need to be worth 3. So we'll just pick any 3 coordinates, but they must have a y coordinate of 3. So I've gone with 0, 3, 4, 3, and -2, 3. I'm going to plot those on the graph. So none across 3 up, 4 across 3 up, -2 across 3 up. Draw my line from one edge of the graph to the other and label it y equals 3. So hopefully you get the idea. You choose any 3 coordinates you like, but in this case y had to equal 3, so my y coordinate, x and y, my y coordinate had to equal 3. And again, to check I've drawn the line in the right place, if I follow my line, it does go through the y-axis. Remember, that's our vertical axis at 3. Okay then, so now it's your turn. You need to add to this same grid lines for x equals -3 and y equals -4. So pause the video, have a go at those now in your book. Okay, so for the first one then, you could have chosen any 3 points as long as the first value in your brackets is -3. So you could have had -3, 0, -3, 1, -3, 2, etc. But your line should be here. It should be a vertical line going down. You should have labelled it x equals -3. And to check, it's going through the x-axis. This is our x-axis at -3. For y equals -4, that's the second coordinate in the brackets, should be -4 for each of your 3 numbers that you've chosen. And if you plotted those and draw the line, you would have a line going horizontally along here, and it does go through the point where y is -4. We label that line y equals -4. Now hopefully you'll notice something interesting about these lines. The x-axis is horizontal, but all of our horizontal lines are called y equals. Our vertical axis is our y-axis, but all of the vertical lines are called x equals. So that's something to make a note of, that the equations of the lines are in the opposite direction to the axis names. So where we have the x-axis horizontal, all of the ones called x equals are actually vertical. Okay, so now that we've had a go at drawing parallel lines, we're going to have a go at drawing other straight line graphs. So the key there is in the title that these are going to be perfect straight lines. So if we get anything that's not a perfect straight line, we'll know we need to go back and have another look. So this time we're asked to complete the table of values for y equals x minus 2. Okay, so that tells us to find the y coordinate. We take the x, we have the x coordinate, and we subtract 2 from it. Now you might want to draw a function machine to help you. So here's my function machine. I've put in all the values of x here. So we were told x is 0, 1, 2, and 3. Our function was x minus 2. So that's our x value minus 2 to get our output, which is our y value. So 0 minus 2 is minus 2. 1 minus 2 is minus 1. 2 minus 2 is 0. And 3 minus 2 is 1. And I can put those into my table. Now again, you might just be able to do that straight away by filling in the table. So use the function machine if you need to, but if you don't, then you can just take the x coordinate and subtract 2 from it and put that in the value of y, because that's what that's telling me. It's telling me the y coordinate is whatever the x one was, subtract 2 from it. Once we've got our table of values, we can now create our coordinates. So our coordinates, remember, are an x and y pair. So we get 0 minus 2, 1 minus 1, 2, 0, and 3, 1, making sure they've got the brackets to tell us their coordinates. Finally, we're going to plot those onto our graph. Now, the most common question I'm asked about drawing a graph is how big should the axis be? Well, if I look at my x-axis, I've got to make sure it starts at least at 0 and ends at least at 3. So I might make it a little bit bigger each side. And my y-axis, the smallest number is minus 2 and the biggest is 1. So it's got to go from minus 2 to at least 1. Again, I might want to make it a little bigger each side. So you've got to use the numbers from your table to help you decide. Okay, so I've made sure that my x-axis had to go from 0 to 3, so 0, 1, 2, 3, so I've gone a bit longer than that. And my y-axis from minus 2 up to 1, so again I've gone a little bit longer on each side of those. We plot the coordinates onto the graph, and we join them with a straight line. So as I said, if your points don't make a perfectly straight line that you can draw with your ruler, then it means you've got one of your coordinates wrong and you need to go back and check it. Don't forget at the end, you need to label the line with the equation that goes with it. All right, make sure you're happy with all of that before we move on to have a go yourself. Okay, so it's your turn then. So you're asked to complete the table of values for the equation y equals 3x, and then have a go at drawing the graph. Now again, down here, that's your hint, so you could use a function machine. 3x means 3 multiplied by the x coordinate. So we're going to take the x coordinate and times it by 3 to get our y coordinate. Pause the video, have a go now. All right then, so if we've used our function machine, we get 0, 3, 6, 9, 12, or we may have put this straight into our table, so 0, 3, 6, 9, 12. Our next step, we should write down our coordinates. So we've got 0, 0, 1, 3, 2, sorry, that should say 2, 6, 3, 9, and 4, 12. Okay, now that we've got those coordinates, then we can draw our graph. So again, x needs to go from 0 to 4 at least, and y from 0 to 12 at least. So we've got some axes here, our x-axis from 0 to 4, and our y-axis from 0 to 12. And we plot our coordinates carefully onto our graph. There we are. Finally then, we join them with a straight line and we label the equation of the line. All right then, so another chance to have another go. This one's a little bit harder. So for this one then, our equation is y equals 3x plus 4. So that's telling us to do 3 times the the x coordinate, and then add 4, and that will give us our y coordinate. So again, little hint here, if you input your x value, times it by 3 and add 4, that will give you your output of y. So you can use the function machine if you want to, or just put your value straight into the table. Once you've drawn your table, find your coordinates and have a go at drawing the graph. Pause the video, have a go now. All right, so let's have a look at the solution for this one then. So if we just use the function machine to start with, we're going to put in our first value of x, which is 0. We're going to multiply it by 3 and add 4, and we get an answer of 4. Then we're going to take our next x value of 1 and put that into the machine. So 1 times 3 plus 4 is 7. Then we'll do 2 times 3 plus 4 is 10. 3 times 3 plus 4 is 13. 4 times 3 plus 4 is 16, and 5 times 3 plus 4 is 19. All right, you may, as I said, have just put them straight into the table as well. You should then have written your coordinates. So 0, 4, 1, 7, 2, 10, 3, 13, 4, 16, and 5, 19. And then we need to plot our graph. So again, check our x-axis, so horizontally we need to go from 0 to at least 5, and vertically we need to go from 4 to 19. So again, we might want to start at 0, 0 there. Okay, so we've plotted the points then very carefully. We've drawn our straight line through them, and we've labelled it with the equation of the line. So well done if you managed to do that more challenging one. Okay, we're now going to move on then to have a look at the graph of y equals x. So again, this is going to produce a straight line, but there's something a bit more interesting about it. So when it says that y equals x, well, that's telling us that whatever the x value is, the y value is the same value. So we can see that here. X is minus 3 and y is minus 3. So if x is minus 2, y is minus 2. So we can fill in our table. So remember, there's nothing here telling me to multiply or add anything else. It's just telling me they are equal to each other, meaning they are the same value as each other. Now, if we write our coordinates down here, we can see that they all repeat. So where we had coordinates of parallel lines, all of one type of coordinate was the same. All the x's were the same, or all the y's were the same. But this time, the x and the y of each individual pair is the same. So let's plot that on a graph and see what that looks like. So if we do -3, -3, so we go along the corridor to -3 and we go down to -3. Then -2, -2, -1, -1, 0, 0, along the corridor 1, up 1, 2, 2, and 3, 3. Join them together with our straight line and label it. And we can see that we get a diagonal line that goes through 0, 0 here. And every point we've got, the x and the y coordinates are the same number. Okay, so we're going to have a look at some problem solving now. This time we've been given the graph of y equals -x. So hopefully we notice then that our diagonal line is still going through 0, 0, but it's going in the opposite direction. We've just had one going in an upwards from left to right direction, and we've now got what we call a negative line, and it's going down from left to right. And that's because we've put in here that y is equal to -x. So whatever the x coordinate is, if x is 1, the y coordinate is the opposite. So if x is 1, y is -1. If x is -2, y is 2. So you need to write down 3 pairs of coordinates that lie on this line. And then you need to write down 3 pairs of coordinates that you know will not be on that line. And try to suggest a reason why you know they won't be on that line. Pause the video, have a go now. Okay, so for part A then, you could have any 3 pairs from this list. Okay, so whatever the x coordinate is, the y has the same number but the opposite symbol. They're inverses, we call that when they're opposites. All right, so just check you've got any 3 of those answers. 3 pairs of coordinates you know will not be on that line. Well, there's an awful lot of those. They could be any pair of coordinates where either both digits are positive or both are negative and the digits of the number are not the same. So for example, you could have 1, 1. That would not be on this line. Okay, because that would be here, 1, 1. All right, 2 digits the same. You could have positive and negative numbers here where the digits are not the same. So 3 minus 4. So 3 along minus 4 down would just be a little bit below the line because our line, the digits are the same. All right, so make sure you've got any 3 that suit that criteria. Okay, finally today then we're going to have a look at a challenge question. So the spring is 10 centimeters long. Jermaine puts different masses on the end and measures the length of the spring. So this is the sort of thing you might do in science. He records his results in the table. It asks you to draw the graph for Jermaine's results, find the length of the spring when he adds 200 grams, and what mass will give a length of 11 centimeters. Okay, you have a choice now as always. You can pause the video and have a go at this challenge on your own and then check the answers afterwards, or you can work through it with me, pausing as you go. Okay, so let's start off by drawing the graph of Jermaine's results then. So we've got our mass, which needs to go from 100 to 250, and we've got our spring, which has to go from at least 12 to 15. Now it's up to you which way round you draw the axis. I've put the mass along the x-axis and I've put my lengths on my y-axis. I've made sure I've labelled them so I know which one is which. My mass I've decided to go along in 50s. So we're constantly going along in 50s till we get to 250. And my length I've decided to count up in 5. So 5 squares per 5 until I've got past 15. Okay, you may have drawn your axes slightly different, but remember the key is whatever you start counting in, you must continue to count the same amount of squares across that same distance. So I've got 5 squares to each 50 going along here. We need to plot the values that we've been given so far. So our first one, our mass of 100 is a length of 12. So we're going across to 100 and we're going up to 12 and we're going to put a point there. Our next one, 150 and 13. So across 150 up to 13. So that's just there. And our next one, we don't know this one here. So we're going to go to our last one. Along to 250 and up to 15 is just there. Now, once we have at least 3, we can draw a straight line through them. Again, I've drawn that all the way across my graph to the axes there. Our second part then, part B, find the length of the spring when he adds 200 grams. So at 200 grams, if we go up to 200 grams and put a point on our line here, we can read across and we can see that that is at 14 centimetres. So I filled that also in my table there. Part C then, what mass gives a length of 11 centimetres? So I need to go up until I get to 11 centimetres, go across to where that reaches my line, which is just here, and down, and that gives me a mass of 50 grams. So once we've got our straight line, because we know it's perfectly straight, we can take other readings from our line. Okay, well, thank you for working through that today. If you need to, do go back and work through it again at your own pace.